Greetings! I want to show you how we can solve basic radical equations. This is one of the data standards and one of the things you will be tested on the final exam, as well as in a quiz on Monday in class. So there are a few steps we're going to use when solving a radical equation. I have an example that one might use here on the left. So first of all, let's look at this problem. Notice I have a square root of the quantity x plus 5, and I've added 7 to it, and I'm saying that that equals 10. So we could say the square root of the quantity x plus 5 plus 7 equals 10. That's our equation. So I'm trying to find something that when I add 5 to it and take its square root and then add 7, I get 10. Okay. Over discussed, but let's move on. My first step is to isolate the radical. I start out basically thinking of that entire radical expression here as if it were my variable itself. So just like when you might have thought back to early linear equations you solved in the past, we're solving for that whole expression. We're going to get everything but that square root x plus 5 part to the other side of the equation. We're going to move it by using our inverse operations. So in this case, what would that look like for this isolating step? Well, I'm going to take my square root x plus 5 plus 7 equals 10 equation, and the thing that's in the way is that 7, because it's added on. It's the only part of the left-hand side that isn't under my radical. So I'm going to subtract it. So now I have square root x plus 5 on the left. The plus 7 and minus 7 add to 0, so I don't need to write anything else. And that equals 10 minus 7, which is 3. So now I have an equation of the form square root of something equals 3. Now I can use the definition of what it means to be a square root. I can basically invert that square root operation. So our next step is to try to get underneath the root, to get in there. And we're going to do that by our step 2, raising both sides to the power that undoes the root. In this case, it's a square root, so to undo that root, I'm going to want to raise both sides to the second power. I'm going to square them. So I'm going to take both sides of my equation and square it. What I get on the left, well, when I square square root, I get the original thing under the root left. And on the right-hand side, I'm going to square 3. Multiply 3 by itself, that's 9. Great. Now notice I'm back to a basic equation, something that's simpler than things we've looked at before. There are no more square roots. So now I can isolate the variable, solve for x in the way I usually would. So I got through my step of getting rid of the root, and now I'm on to step 3. Well, how in this case would I get x by itself? Well, the inverse operation to adding that 5 would be subtracting it. So x equals 4. Now, it might be there'd be more steps at this point if the way that x showed up under the root was more involved. But that's that third step. I'm going to solve for the variable. As a reminder, I've indicated the 3 possible things you might see under the root and how you would do that. Last thing, whenever you're doing a problem like this, always go back and check. Take the value that you've gotten for x, or the variable, in this case I said x equals 4, and check that the original equation works. So I'm going to write, does the square root of my solution 4 plus 5 plus 7, what does that equal? Oh, well, that's 4 plus 5 is 9, so this is the square root of 9 plus 7, or the square root of 9, which is 3 plus 7. Oh, 3 plus 7 is, in fact, 10. That is what the right-hand side of the equation needed to be. If I go back and look, so I verified my solution. I can really say that the solution to this problem is x equals 4. Here's a second example. We have the cube root of the quantity 2x plus 4 minus 3 equals 7. So here our big radical chunk is that whole expression, cube root of 2x plus 4 minus 3 equals 7. I want to get that chunk by itself on one side of the equation as my first step. So I look at my equation and I notice that the other thing on both sides, or the other thing that's on the left-hand side, is a 3. So if I were to add 3 to both sides of that equation, now I have cube root of 2x plus 4 equals 10. Now that's more doable because now the only thing on the left is a cube root, and that means I can undo that cube root just by raising both sides to a power. So that's my second step. I'm going to raise both sides to the same power. Because I have a cube root in this case, I need to raise something to the third power to undo that cube root. Cube of my left-hand side equals cube of my right-hand side. What does that leave me with on the left? Just the thing under the root, 2x plus 4. And on the right, 10 to the third power, that's 10 times 10 times 10, which is 1,000. So now I'm going to keep solving. I'm just trying to get x by itself. So as my next step, I'm going to subtract 4 from both sides to undo that added 4. So now I have 2x equals 996. And now I'm going to undo that multiplication by 2. I'm going to divide both sides of the equation by 2 in order to undo the multiplication. And I get x equals 498. So to verify my work, that's always that last step, I want to check. So I'm going to take the original equation, cube root of 2 times my value, 498, plus 4, subtract 3, and see whether or not that's equal to 7. Well, under the root, 4 times 498, that's 996. Add 4 to that, that gives me my 1,000. So I do have the cube root of 1,000 there on the left. And I've subtracted 3. So I'm getting 10 minus 3, that's my left-hand side. And surely enough, that does equal 7. Yay! It satisfies the original equation. And that is the set of steps that you can use every time. Isolate the radical, then raise both sides to a power to get rid of the root, then solve for the variable that was hidden underneath, and check your solution. You'll notice I've included a third case, which you may see in some of the problems, and that's when it turns out that the thing under the root was actually a multiple of x to the power plus or minus something. And there are examples like that in some of the problems we'll do in class.